Welcome back to Text Transformation with Red. Today what we'll be doing is we'll be jumping right into it. And the first feature we are going to implement is the parsing rules for recognizing numbered headings. So if you remember from the previous video, the syntax we're using for numbered headings is very similar to what you find in Markdown. So the pattern is going to be, or the pattern to look for to recognize is a pound sign, some space, and a heading title. And for a level 2 heading, it'll be the same, very similar pattern. There's going to be two of them, two pound signs, some space, and a heading title. And the objective, what we're trying to get to, or the result we're trying to achieve, is as a result of parsing each one of these lines, we're going to be building up a block of data. So after parsing after successfully matching the first line here, this is what I would expect or after parsing these two lines, this is what I would expect the data block to be. So this is where I'm trying to get to, is to generate a block, and it has a word called h1, followed by a string, followed by another word called h2, and another string. And the reason why I'm doing this is that in Red and Rebel, this concept, or the central idea, is that code is data and data is code. And what that means is that even though this is a block of data, it's also code. And if it's code, we can execute it to get some kind of other result. So what we're trying to do is create a block of data, and somewhere in my code base, I'm going to have going to make the assumption that there's a function called h1. It takes one parameter and it does something with it. And same thing with this word h2. I'm going to assume in my code base is the function named h2, and it also takes a parameter and does something else to it. And as an example, this here is how I would expect. This is what I would expect to see somewhere in my code base is h1, which is a function that takes one parameter, and in here, some code to do something with whatever is passed into it. And in our case, what I would like to do is to simply have a function return, take this heading, and then insert this tag and append this other tag and just return it. It could be printed, it could be written to a file, it could be, there's various options. But for now, all I'm interested in is taking in this heading and having this function add these tags to it. And something similar for this function h2, I would have a function called h2, and I would have it, have some code in it that would insert this tag h2 and insert this closing tag h2, and then just return it. And the idea being that, as I mentioned, in Red and Rebel, data is code and code is data. So the idea being that once we finish parsing and create this block of data, which is essentially very similar to which you could refer to as an abstract syntax tree, or an abstract representation of our data. I'm basically using this as an intermediate representation of the data, and we can run it. So basically, at the end of the parsing, we will get this block of data, and then I will call reduce on it so that it goes through this block of data, and whenever it encounters a word, the interpreter will figure out that there's a word called h1. It's a function, it takes one parameter, and evaluate that function and return the result back. So this is the idea, and this is the general design that we will be working with, is basically build up an abstract representation of our data, Each one of these items will have a function defined for it. So when we get to parsing a list, for example, we'll have a function called list that takes in a block of data. In our case, list items, and then do something with it. So this is the general structure of our project. Now, just to start off with, I just created a word and bound to it these 3 lines. This is going to be our sample data. Later on, as our examples get larger and larger, we'll move this to a file. But this should be fine for now. And we'll just jump right into parsing. So there's this function called parse. It takes a parameter and some rules. And in our case, the rule, and we'll define this rule, we'll just randomly call it numbered heading. And now we're going to describe what a numbered heading looks like. So what is the pattern? Well, numbered heading is basically going to be, if we look at the input, we can express it like this. There's going to be some pound signs followed by some space, and there's going to be a title right up to this invisible character. We don't see it, but up to the new line. So basically what we're saying is that some is a keyword. Some is a word that's used in the parsing dialect, in the parsing function. That means that there needs to be at least one of whatever follows. There could be more than one, but at least one. So what we're saying here is that there needs to be at least one pound sign, and then at least one space. There could be more than one space. It doesn't matter, but at least one. And then what follows next is going to be what we can refer to it as the title, and right up to the new line. So this is basically the gist of it. This is how we can express a pattern. Now we're going to give this a try and see what happens. So we're going to start up our red interpreter, and we are going to load and evaluate this program. So we use the do keyword. This basically loads something up into memory and then evaluates it. So mark.red. What does that say? Invalid rule or usage of ruled. And it's referring to title. Okay, that makes sense because I put the word there, but there's nothing, there's no definition for it. So it doesn't know what to do with this. So we're going to massage this a little bit. We're going to introduce this word called copy. And basically what copy does is it says copy, the way copy works is that the meaning is copy into what follows the result of the rule right after it. So in this case, we're saying copy anything up to the new line and stick it in this this variable or this word called title. So let's try that again. False. Why is that? Why are we seeing false here? Well, the way that parse works, You give it some input, you give it some rules, and if it successfully goes through all the rules, then parse will return true, meaning success. If it is not able to go through the rules, if it's not able to take the input and apply all the rules to it, this is interpreted as a failure. So this tells me that the rule that we define here, or the rules that we have defined here, for some reason is not going through to completion, and it's returning a failure. Now the reason for this is that we have a lot of input here. We have 3 lines, and basically the way that parse works is that it goes through the sequence of rules, and if there's still input left, and it's not able to reach the end of that input, then it will return a failure. This means I was not able to go through all the input that you gave me up to the end, is essentially what this means. So what we'll do is basically we have many of these. So basically what is happening is that it's going through the first it's going through the first line of input, going through these rules, and then it stops for some reason. It doesn't know what it doesn't have the information that it needs to keep going. So I'm going to introduce this word here, any, and what any does is that it will try to repeatedly match the rule or the rules that are in this block here. So what essentially, by introducing this word any, we're saying trying to find as many numbered headings as you can. So we will try that and see what the result is. False. Why is that? This all looks fine. We're telling it to go up to the new line. But this is the problem. We're telling it to go up to the new line, and it stops there. It stops at right before the new line. So what we would actually like it to do is, once it hits the new line, we want it to skip it or go through it. There's a couple of ways to do this. For now, we'll just use through new line. So basically, if we look at this rule again, it means match some pound signs, match some space, and then copy whatever is up to the new line, stick it into this variable, and then go through the new line. And by adding this rule, what happens is that we get to the new line, we go through it, which brings us down to the next line. So let's give this a spin. And now this works. So this is an indication that parse was able to take our input and go all the way to the end of the input using the rules that we've applied to it. So this is a good sign. Now let's take this. Let's take a step back and see what we're trying to do here. We're trying to get parse to generate this block of data for us. So we're copying whatever we find up to the new line and stick it in title. So I'm making an assumption that title will hold these strings, and we can test this. So in the parse dialect, we can have it run some code after matching some rules. So the way we do this is by introducing the parentheses. And essentially, what we're doing here is that we're telling parse that whenever you encounter these parentheses, execute whatever code is in there. And that code can be any red code. So for now, just to demonstrate this, what I want to do is just print the title. So we're going to go through the sequence of words, these rules, this pattern, and then when we get up to the new line, we're going to have it print the title before moving on to the next line. So let's give that a try. All right. So that works nicely. Now, again, this is where we're trying to get to. We want to create a block of data. So we want parse to create a block of data for us. So whatever we find here and stick in the variables, ideally what we like it to do is add those to a block. So how do we do that? Well, parse has this, red has a word called collect. And collect does exactly that. It collects things into a block. But using collect is not enough. It usually comes, it's typically used with another keyword called keep. So, and basically keep basically just is an instruction that says whatever comes after keep, put that in the block that collect will be creating. So if we change this from print to keep, and we've added this word here called collect, which essentially will have parse return a block. Combining these two should give us something like this: heading, title, a level 2, title, etc. This is what I'm expecting. Let's try it out. And there you go. So by introducing the word collect and in combination with keep, we are parsing some input, keeping some pieces of it, sticking it into a block, and then parse returns that block. Okay, so we're halfway there looking at where we're trying to get to. We have the headings that are being collected into a block. So how do we handle adding these words here, H1, H2, H3, etc.? Well, what are the patterns? Well, when there's £1 sign, this means it's a level 1 heading. If there's £2 signs, it's a level 2 heading, and so on. So what we can do is we can maybe test the length. We can maybe see how many pound signs we're collecting, or that we're matching, and use this function that is available in red called length. And you can give it a block, you can give it a string, and it basically just gives you the length of that. So if we were to have pass it in this string of 1 character, returns 1. If we stick 2 characters in there, it returns 2, and etc. So I think this is what we'll be using, and basically try to figure out a way to generate these words H1, H2, H3. So let's see how we do that. So when we saw earlier, copy, when we introduced the word copy, the way copy works is it says copy into this variable or this word the result of matching the rules that come after it. So we can use something similar here. We'll say copy into the a variable level a number of pound signs. I'll just move this here for now. And we're going to do something similar for level. So again, in combination with collect, we'll be creating a block of data. In here, we're putting something in a variable called level, which will presumably be one or many pound signs. We're copying something into, sticking something into a variable called title, which is the heading title. And when we say keep level, it should stick that into the block that collect will be creating for us, followed by the title. So let's just give this a try. What I'm expecting is that we will get something like this, and then a heading, and then something like this, followed by a level 2 heading, etc. This is what I'm expecting. Let's give that a spin. And there you go. So we're halfway there. So as I mentioned, whenever we have something in these parentheses, it's an indication to the interpreter to execute or evaluate some code. So as I mentioned, what we like to do is calculate the number, calculate the length of whatever string gets added to level. So if I modify this, whatever's in parentheses here, instead of seeing pound sign, 2 pound signs, I should actually be getting the number of pound signs. Because if you remember, length gives us the length of items in a particular in the input, whether it be a block or a string. So let's give that a try. All right. So now you can see how this is starting to look like H1, H2, H3, etc. So basically, we just want to stick an H in there, and then we're all set. So that we can get H1, H2, H3. So the way we'll do this is by using a rejoin H, and then the length, the result of evaluating length of level. So what rejoin does is kind of like a concatenation. It's like a concatenation function, but it does a bit more than that. You can see here, join, it tells you what it does. But basically, it's prefixed by re, and re is basically a shorthand for reduce. So as if you remember, reduce basically looks at whatever comes next. If there's code, for example, it will evaluate that code and then replace it with the result of the evaluation. So it will reduce. It will reduce. It will evaluate the code and reduce it to its the result of its evaluation, and then join it to H. So if we give that a try, let's see. Look at that, H1, H2. But I'm noticing here that this is still a string. I don't want a string, I want a word, because I want to be able to reduce this block of data. later on as though it was a function call. So a string is not a function. I need a word here. So let's just do this to word. So if we follow the logic here, it will evaluate, will give us, this call will return to us the length of the string passed into it, and then append it to, join it to the letter H, and then this will be passed to word, which should convert that string into a word. So what I'm expecting now is exactly what we're looking for, H1, a heading, etc. So let's give that a try. Oh, I guess I need to save. Look at that, exactly what we're looking for. I guess the last thing I want to do, we don't have to do this now, but we'll just do it anyways, is that this block that you're seeing is being returned by parse because we're using the word collect. What I would like to do, I'm just going to add this word. This form here is called set word, and basically what it does is like a variable binding, not exactly, but this will make the word doc tree point to whatever's returned by parse. In this case, it will be this block of data. And then later on, we can just do a bit more stuff with that. So let's try that again. And then if I type doc tree, I should see exactly the same thing. Yeah, so now this word doc tree is pointing to this block of data. So this wraps it up for today. We've gone through a lot, introduced a lot of concepts. In the next lesson, what we will be doing is doing the parse rules for unnumbered headings, which is essentially very similar. The only difference is we'll be using equal signs for that. So the next lesson should be pretty short because we'll be doing exactly the same thing. We'll be using exactly the same rules, which should make our job a little easier. So thank you for sticking it out, having patience as we learn how to transform text using red and the parse dialect. See you next time.